This is SpaceTime, Series 25, Episode 62, for broadcast on the 7th of June 2022. Coming up on SpaceTime, a hidden trove of massive black holes discovered in dwarf galaxies, ESA's upcoming JUICE mission to Jupiter, and it seems the effects of the Tonga volcanic eruption earlier this year reached all the way into space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a previously overlooked treasure trove of large black holes hiding deep inside dwarf galaxies. These newly discovered black holes, reported in the Astrophysical Journal, are providing astronomers with a glimpse into the life story of supermassive black holes, the monsters found deep at the center of giant galaxies, including our own Milky Way. Like all big galaxies, the Milky Way was built up through mergers of many small dwarf galaxies. For example, right now, two dwarf galaxies, the Large and Small Magellanic Clouds, which are visible in the southern skies, are slowly merging into the Milky Way and will eventually be consumed wholly by our galaxy. Scientists are pretty sure now that all galaxies contain a central giant black hole of some description. In the case of big galaxies like the Milky Way or Andromeda, these are supermassive black holes, millions to billions of times more massive than the Sun. In fact, the supermassive black hole at the center of the Milky Way, called Sagittarius A star, has some 4.3 million solar masses. Smaller dwarf galaxies are also thought to contain a central black hole, although little is known about their likely masses. Still, it's thought that as each dwarf galaxy merges into the Milky Way, it'll bring with it a central black hole, possibly tens or hundreds of thousands of times the mass of our Sun, which will eventually be destined to be swallowed by Sagittarius A star. But exactly how often dwarf galaxies contain massive black holes, and exactly how big those black holes are, remain unknown quantities, leaving a key gap in science's understanding of how black holes and galaxies grow together. The new discovery helps fill this gap by revealing that massive black holes are many times more common in dwarf galaxies than previously thought. The study's lead author, Magda Palomira from the University of North Carolina at Chapel Hill, says these black holes were previously hiding in plain sight. See, as their name suggests, you can't see a black hole. But what you can do is see a black hole's effect on surrounding stars and material. And even at longer distances, they can be typically detected when they're feeding on material in their accretion disk. The material gets too close to the black hole and it forms an accretion disk, just like water going around the sink before it drains down the plug hole. Now, as this material is on the accretion disk, it's being crushed and torn apart right down to the subatomic level. A lot of energy is being released in this process, and this energy is a sign that there's a black hole there. It's only once the material on the accretion disk passes a point known as the event horizon that it disappears forever and falls into the singularity, the point where science's understanding of the laws of physics breaks down. The problem is, while growing black holes glow with a distinctive high-energy radiation, young newborn stars do exactly the same thing. Traditionally, astronomers have differentiated between feeding black holes and new star formation by taking very detailed spectra, looking for specific Doppler shifts and elemental features. When the authors applied these traditional tests to galaxy survey data, they found some of the galaxies were sending mixed messages. Two of the tests would indicate feeding black holes, while the third would indicate star formation. Now, previously, these sorts of results would be rejected as being ambiguous. But the authors in our study wondered whether or not this could be a sign of undiscovered black holes in the dwarf galaxies they were studying. The third, sometimes contradictory test was usually more sensitive than the other two to specific properties of dwarf galaxies, their elemental composition, mainly primordial hydrogen and helium from the Big Bang, and also their high rate of star formation. Now, theoretical simulations suggested that the mixed message test results matched what theory would predict for a primordial composition, a high star-forming dwarf galaxy containing a growing supermassive black hole. So, Palomira and colleagues began constructing a new data set of growing black holes with attention both to traditional and mixed message types. She obtained published measurements of visible light spectral features to test for black holes in thousands of galaxies found in earlier surveys. These included ultraviolet and radio data, ideal for studying star formation, and they have an unusual design. Whereas most astronomical surveys selected samples that favour big and bright galaxies, these were complete inventories of huge volumes of the present-day universe, and they included lots and lots of dwarf galaxies. By looking at this whole census, the authors found there was a new type of black hole that always appeared to be showing up in these dwarf galaxies. In fact, more than 80% of all the growing black holes found in dwarf galaxies belong to this new type. Now, after checking just to make sure there couldn't be some sort of extreme star formation, exotic astrophysics, or modelling uncertainties going on to explain the spectral data, the authors concluded that what they were seeing really were newly identified black holes. They're now convinced this is a new type of black hole, and could all be the basic building blocks of supermassive black holes like the one we find in our Milky Way galaxy. And that's important because one of the big problems we have with supermassive black holes is that we don't just find them today, we also find them in the very early universe, at a time when there's no logical way they could have grown that big simply by lots of merging. That means there had to be another explanation. This is SpaceTime. Still to come, we look at the European Space Agency's JUICE mission to Jupiter, and it seems Tonga's volcanic eruption back in January was so powerful it reached all the way up into outer space. All that and more still to come on SpaceTime. Let's take a break from our show for a word from our sponsor, Nordvpn. Now, it's occurred to us that you may not actually know what a VPN is. Well, VPN stands for Virtual Private Network, and basically it's like making you invisible from the bad guys out there on the internet. Hackers are desperately trying to find your bank details, your email addresses, your contact information, and that of your family and kids as well. A virtual private network shields you from that by routing you through different computers in different countries, keeping you safe. And it's really important if you're, say, using the Wi-Fi at the airport. Well, they say it's secure, but it's really not. It's really easy to hack, and so it's really easy for the bad guys to get onto your laptop and find out all they want to about you and your family. And that's where Nordvpn comes in. It acts like a brick wall, keeping you safe and secure while you browse online. And because it's so good, Nordvpn won't slow you down. In fact, in some cases, Nord will make things even faster. Another great feature of Nordvpn is that you can access their servers through more than 60 different countries. And that lets you reach geo-blocked sites and content that you may not otherwise be able to get from your local server. And the icing on the cake is that it's all really affordable. And to get you started, we have a special offer for SpaceTime listeners. You can grab your exclusive Nordvpn deal by going to nordvpn.com/StuartGary and use the code StuartGary, all one word and in lowercase at the checkout, to get a huge discount on your VPN plan. Plus, we'll give you 1 month for free, and there's extra protection as well with a free anti-malware feature. And of course, it all comes with Nordvpn's 30-day money-back guarantee. So what have you got to lose? Give it a try today. Just go to nordvpn.com/StuartGary, use the code StuartGary at the checkout, and get a huge discount on your plan, plus 1 additional month for free, extra protection with an anti-malware feature, and of course, there's the 30-day money-back guarantee. This is an offer too good to miss. So give Nordvpn a try. You won't be disappointed. And of course, we've got all the links and details in the show notes and on our website. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
The European Space Agency's Jupiter Icy Moons Explorer, or JUICE mission, is slated to launch in April 2023. That's less than a year from now. JUICE will be on an 8-year journey to search for signs of life on 3 of the icy Galilean moons orbiting Jupiter. It'll arrive at Jupiter in July 2031 to explore the largest planet in our solar system and 3 of its 79 moons, Ganymede, Kalisto, and Europa. Then in December 2034, the spacecraft will enter orbit around Ganymede for a close-up scientific mission, becoming the first spacecraft to orbit a moon other than the moon of the Earth. Other than the Sun, Jupiter is the largest body in our solar system. In fact, it's so big it contains more mass than the rest of the solar system combined, other than the Sun. But it's a long way away. The Jovian system is located almost 780 million kilometers away from the Sun. The average temperature on the surface of the icy moons orbiting Jupiter is below minus 140 degrees Celsius. It's to this dark icy world where the JUICE mission will be traveling. Besides fundamental questions on the formation of planets and their moons, the mission will also try to determine if the ice moon Europa and Ganymede, the largest moon in our solar system, bigger than the planet Mercury in fact, could potentially provide habitat suitable for life as we know it. You see, both these distant frozen worlds have subsurface oceans kept liquid by gravitational tidal forces generated as the moons orbit around their giant host planet Jupiter. These oceans are thought to have all the properties which are not only needed for the occurrence of life, but which also provide environments in which life can exist long term. And so that's what the JUICE mission's going for. To achieve its aims, it carries 11 scientific instruments. There's a 400 megapixel high-resolution camera system, a visible and infrared imaging spectrograph to observe tropospheric cloud features and minor gas species on Jupiter, and to investigate the composition of ices and minerals on the surface of the 3 moons. Also on board will be an imaging spectrograph to characterize exospheres and aurorae on the tiny moons, including plume searches on Europa, and to study the Jovian upper atmosphere and aurora. Another spectrometer will study Jupiter's stratosphere and troposphere and the exospheres and surfaces of the 3 moons. There's a laser altimeter to study the topography of the ice moons as well as tidal deformations of Ganymede. An ice-penetrating radar will examine the subsurface structure of the moons all the way down to a depth of 9 kilometers. A magnetometer will study the subsurface oceans of the moons and the interaction of the Jovian magnetic field and the magnetic field of Ganymede. There's also a suite of 6 sensors to study the magnetosphere of Jupiter and its interaction with the Jovian moons. These will measure positive and negative ions, electrons, exospheric neutral gas, thermal plasma, and energetic neutral atoms. A radio and plasma wave experiment will characterize the plasma environment and radio emissions around the spacecraft. A gravity and geophysics radio science package will study the gravitational field of Ganymede and the extent of internal oceans on the icy moons, and it will also investigate the structure of the neutral atmospheres and ionospheres of Jupiter and its moons. And finally, there's an experiment which will generate very specific signals transmitted by JUICE's antennas, which will be received here on Earth by very long baseline interferometry in order to perform precision measurements of gravity fields of Jupiter and its icy moons. This report from the University of Bern.
Next stop in the search for extraterrestrial life, Jupiter's icy moons, Ganymede, Kalisto, and Europa. In 2023, the Jupiter Icy Moons Explorer, JUICE, will leave Earth, heading towards Jupiter. After a 7-year journey, it will enter the Jovian system and start exploring the 3 moons during close flybys. JUICE then will orbit its primary target, Ganymede. At 1.5 times the size of Earth's moon, Ganymede is the largest moon in the solar system. There is evidence that Ganymede harbors an ocean deep beneath its 150-kilometer thick ice crust. Moreover, the gravitational interactions with Jupiter provide energy in the form of heat, a necessary condition for the emergence of life. Kalisto is also covered with a thick ice crust, yet it is uncertain whether an ocean lies underneath. The Moon's heavily cratered appearance suggests that no geological activity has ever reshaped its surface. Europa's surface is much younger and is constantly being reshaped by tectonic activity. Its ice crust is also much thinner, barely more than 15 kilometers thick, and the vast ocean beneath contains presumably more water than all the Earth's oceans combined. The resemblance of these subsurface oceans to Earth's deep sea environment suggests that they can be habitable for microbial life. Europa is widely considered the most promising place to search for life beyond Earth. JUICE will investigate the atmospheres, surfaces, and interiors of the three moons. The University of Bern provides the NIM, Neutral Ion Mass Spectrometer, an instrument designed to measure the chemical composition of the atmospheres. Passing Europa, JUICE will try to sample ocean water erupting from cracks in the ice crust and analyze it for organic molecules that may indicate the presence of life. This mission may prove to be a giant leap towards answering the question of whether life beyond Earth exists after all.
This is SpaceTime. Still to come, a new study shows the effects of the Tongan volcanic eruption in January reached all the way out into space. And later in the science report, scientists are showing that dogs already came in all sorts of shapes and sizes as far back as the Bronze Age. All that and more still to come on SpaceTime. When the Hunga Tonga volcano erupted back on January the 15th this year, it sent atmospheric shock waves, sonic booms, and tsunami waves right around the world. Now, scientists are finding that the volcano's effects also reached all the way out into space. The findings, reported in the journal Geophysical Research Letters, are based on data from NASA's Ionospheric Connection Explorer or ICON mission and the European Space Agency's Swarm satellites. They found that in the hours following the eruption, hurricane-speed winds with unusual electric currents formed in the ionosphere, Earth's electrified upper atmospheric layer at the edge of space. The study's lead author, Brian Harding from the University of California, Berkeley, says the volcano created one of the largest Earth-generated disturbances in space ever seen. The effects are allowing scientists to test poorly understood connection theories looking at how the lower atmosphere interacts with space. ICON was launched in 2019 in order to determine exactly how weather from the Earth and weather from space interact. It's all a relatively new idea, supplanting previous assumptions that only forces from the sun and space could be powerful enough to create weather at the edge of the ionosphere. But in January, as the spacecraft passed over South America, it observed one such earthly disturbance in the ionosphere, which was triggered by the South Pacific volcano. It seems when the volcano erupted, it blew a huge plume of gas, water vapor, and dust high into the sky. The explosion also created huge pressure disturbances in the atmosphere, leading to really strong high-level winds. And as these winds expanded upwards and outwards into thinner atmospheric layers, they began moving faster. By the time they reached the ionosphere and the edge of space, the ICON spacecraft was clocking wind speeds of up to 730 kilometers an hour, making them the strongest winds below 200 kilometers in altitude measured by the mission since its launch. In the ionosphere, the extreme winds also affected electric currents. Particles in the ionosphere regularly form an east-flowing electric current called the equatorial electrode jet, which is powered by winds in the lower atmosphere. But after the Tonga eruption, the equatorial electrode jet surged to 5 times its normal peak power. And dramatically, it even flipped direction and began flowing westwards for a short period. Scientists were surprised to see the electrode jet reverse direction because it's something that was happening on the Earth's surface. That's something they've only previously ever seen with strong geomagnetic storms generated by the sun. So this new research is adding to science's understanding of how the ionosphere is affected by events not just from deep space above, but also from the ground below. The Hunga Hunga Undersea volcano rises some 1.8 kilometres above the seafloor. It's 20 kilometres wide and is topped by a submarine caldera 5 kilometres in diameter. The rim of the Hunga caldera breaks the surface at several places, forming a train of small islands. The cataclysmic January 15th eruption blasted a plume of ejecta some 50 kilometres into the sky. It generated a 15-metre tall tsunami and unleashed as much energy as 18 megatons of TNT, making it the most powerful eruption on Earth in the past 30 years. Satellites caught the massive blast and shockwave from space, and sonic booms from the eruption could be clearly heard 2,300 kilometres away in New Zealand. Estimates suggest the eruption had a volcanic explosivity index, or VEI, of 5 or 6. Now that's around the same as the 1991 eruption of Mount Pinatubo in the Philippines and of Krakatoa in Indonesia in 1883. The VEI scale, which is logarithmic, has a maximum reading of 8. Mount St. Helens was a 5. The evolution of Hunga Hunga has been stunning. Scientists have been watching it closely ever since new land rose above the surface during an eruption in 2015. That joined 2 existing islands created during an earlier eruption in 2009. But the January 2022 eruption blasted away all the land created in the 2015 eruption, along with large chunks of the 2 older 2009 islands, which were part of the caldera's western and northern rim. For the first few weeks of 2022, the volcanic activity seemed typical enough, with intermittent small explosions of tephra, ash, steam and other volcanic gases as magma and seawater interacted in a vent near the middle of the island. The ongoing eruptions were reshaping the landscape, enlarging the island by adding new deposits of ash and rock to the growing volcanic cone. By early January, the island had expanded by 60% compared to before the activity started back in December 2021. Then on January the 13th and 14th, an unusually powerful set of blasts sent ash surging into the stratosphere. The entire island was completely covered by 1/10 of a cubic kilometre of new ash. Then, the major eruption on January the 15th blanketed nearby islands with ash, dust and debris. The massive eruption was thought to have been caused by hard rock in the foundations being weakened by earlier blasts. That allowed the partial collapse of the caldera's northern rim, which allowed the surrounding Pacific Ocean to rush into an underground magma chamber. Now, the temperature of magma usually exceeds about 1,000 degrees Celsius. On the other hand, the temperature of seawater is closer to around 20 degrees Celsius. The eruption of Hunga Hunga shows that the mixing of the two can be incredibly explosive, especially in the confined space of a magma chamber. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that Australian rainforest native bird populations are in decline in the wake of the catastrophic Black Summer bushfires, which devastated vast regions of the country 2.5 years ago. The findings by the University of New South Wales looked at the impact of the 2019-2020 wildfires on the ancient Gondwandian rainforests of the Australian World Heritage Area, which were burned for the first time in recorded history. Scientists found the most affected rainforest birds were species that eat insects, leaves, or fruit. Of particular concern were fruit-eating birds such as the Wampu fruit dove and the paradise riflebird, which have significant roles in rainforest regeneration. Australia's Black Summer bushfires burnt out over 186,000 square kilometres, killing more than 3 billion terrestrial vertebrate animals, including many highly endangered species, some of whom have been driven to extinction. The massive wildfires also destroyed almost 6,000 buildings, including 2,779 homes, and they killed at least 34 people. Smoke from the fires crossed the Pacific Ocean, affecting not just New Zealand, but also Chile, Argentina and South Africa, before being detected again in Western Australia after completely circling the globe. A new study claims that beliefs in ghosts, in mind reading, telekinesis and other supernatural pseudoscience claims are all linked to differences in how people think. The findings, reported in the journal PLOS ONE, are based on a review of evidence from 71 earlier studies of cognitive function and paranormal beliefs. The authors found that believing in the supernatural was most common in people who tend to think instinctively, without much reflection. They tend to be strongly influenced by confirmation bias, only focusing on information that appears to back up their existing beliefs. They have poor reasoning skills and think everything happens for a reason, rather than acknowledging the random nature of life. A new study has found that dogs have been coming in all shapes and sizes well before the arrival of the Bronze Age. The findings, reported in the Journal of the Proceedings of the Royal Society B, are based on a study of canine jawbones ranging from 3,000 to 8,100 BCE. The authors found that the jaws of these ancient dogs varied from very small, similar to modern-day Pomeranians and Dachshunds, right through to larger sizes, similar to the modern-day Golden Retriever and German Shepherd. However, although there was considerable variation in head and jaw shape, the variation was still less than that seen in modern dogs, and there were none of the extreme head shapes seen in modern-day short-faced dogs, such as bulldogs and pugs. Google's developer conference has previewed the next generation of technology on its way to consumers. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
So Google's I.O. Developer Conference had two keynote events. One was for the general public and one also was for developers. Now, this was an event where actually they had people in attendance because over the past couple of years, of course, you couldn't have people in attendance. And many of the other conferences, continue to sort of have a digital component or be online. But Google bit the bullet and had people there, which was great to see. And the first keynote, again, aimed more or less at the public, but for developers as well. But it was about 2 hours long. The developer-specific keynote is 57 minutes. Now, if you go to io.google, you can find out all about the developer conference there, see the two keynotes. But if you go to YouTube, you'll find a lot of people have produced cut-down versions of that 2-hour conference. Look, you get to see Android 13. That's obviously the next version of Android coming later this year. And one of the features, for example, is something that iOS, iPad, and Mac users have enjoyed for years, which is the ability to copy something from one device and paste it to another device that you own. There's also the ability for tablets to be taken seriously again by Google. They actually cancelled their tablets 2-3 years ago, even though companies like Huawei and Samsung and Lenovo and others still have tablets running Android, although, of course, Huawei's don't actually have Google Play Store. But even so, Google showcased 20 apps that it had designed for the tablet's dimensions. Now, that's very important. There were some third-party apps there too. But that's very important because a lot of the apps were just stretched-out phone apps, which look terrible on a tablet screen, whereas Apple, back in 2010, when it first launched the iPad, it got developers to use every pixel of that larger, beautiful canvas that a tablet offers. And developers have never stopped making superb tablet apps on iPads, much more so than on Windows and Android devices. Google is finally taking tablets seriously again, and hopefully developers are now going to be encouraged to take tablet apps on Android as well, because it's a great shame for Android users not to have great tablet apps. There's also impressive advances in AI. There was an AI kitchen, I think it's called, that had an app called Lambda 2, and here they just asked this app to create a series of lists about what to do if you wanted to plant a new garden. And in seconds. It produced a whole bunch of different steps you should take, and it had tips on best things to grow in a small area on your balcony, for example. I mean, it was very intelligent. It's almost making me wonder it's going to replace humans, all this AI one day. That was a little example of how AI has been improved under Google. They also added 24 new languages to their Google Translate. Many of those are from Africa, and they talked about how 300 million people rely on these languages, and previously, it wasn't available. And Google Translate is so advanced these days. I mean, I've been showing people who speak languages like Greek or Italian or French or Spanish, I mean, those sorts of standard languages that have been looked after by Google Translate for some years. And Google is always improving the translation, so much so that we really do have the closest thing ever to the universal translator from Star Trek without actually having the universal translator yet. Another example of this universal translation was a demo, a prototype of these AR glasses that could display the translated text of what someone was saying in English to relative in Spanish. And they could see it and they could have this free two-way conversation. Extremely cool. Look forward to seeing that when something like that comes out from Google later this decade and from Apple and everybody else. Plenty more was showcased, including a new Pixel 6a phone, as well as sneak peeks of the long-rumored Pixel smartwatch and early looks at the Pixel 7 and Pixel 7 Pro smartphones. So go to io.google to watch the full event, and you'll really enjoy it if you're into sci-fi and tech.
Now, Apple showcased a range of accessibility improvements for its iPhone, its iPad and Mac. Tell us about it.
Yeah, these are coming later this year. It's rare for Apple to pre-announce some of this stuff, but clearly this was part of the Global Accessibility Day. They had something called door detection where you could hold a phone up in front of you and you could see how far away you were from a door if you were visually impaired. And also read what was on the door. So that Apple has a little video in its newsroom section on that. They also had the ability to control Apple Watches from the larger screen size that is on your iPhone. So for people who find that Apple Watch a bit too small but still want the Apple Watch. And there was also improvements to voiceover languages and more. So everyone is working really hard to make technology more accessible for everybody. And then next week, we're going to talk about Apple's Worldwide Developer Conference. They will have their own, 1 or 2 hour keynote showcasing the latest in iOS 16, iPadOS 16, macOS 13, watchOS 9, tvOS 16. So we're going to have tons of cool stuff to talk about next week as well.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.